So if we take a moment to remind ourselves about the equation a sub 1 times 1 minus r to an n power over 1 minus r. Now, I need to explain something to you, and you need to stick with me here, okay? When you take 1/2 and you raise it, which is a common ratio that will show a decreasing geometric sequence, when you raise it to a big power, the outcome is going to be very small. Okay? And when we talk about an infinite geometric series and the common ratio is going to be less than 1, if this is an infinitely big number, 1 over 2 is going to be, the bottom is infinitely big. That means this thing is going to be very, very close to approximating 0. The bigger the power, the closer this thing is going to be to 0. So if we say it's an infinite geometric series, this is going to be so small, it's going to be so close to 0, we are infinitely close to 0, we wouldn't be able to tell the difference between 0. So what happens when you get an infinite geometric series and r is a common ratio that's less than 1? This basically becomes 0. So you're saying the numerator of this thing is equal to the initial value times 1 minus nothing. So we could really say that it is a sub 1, which is the initial value. And when you talk about an infinite geometric series getting bigger and bigger, in no way does that affect the 1 minus r on the bottom. So essentially, the sum of an infinite geometric series is simply that ratio, which is actually much simpler than this crazy monster. But that's because we're getting infinitely big, and you can only take the sum of an infinite geometric series only when it is a decreasing geometric series, meaning this only is true when r is less than 1 and in fact greater than 0.